Hello, my name is Mark Jerome, and I'm going to discuss the specifics of duct sealing. The agenda for this section are primary goals, types of incentive pathways, before you begin, initial inspection, keys to a complete job, and job site safety. The primary goals are to prevent wasted heat and cooled energy, durable installations that last, improve comfort and indoor air quality. So we'll focus on the graph below. You can see that on average, 72% of the air that's heated by the heat pump or the electric furnace actually gets into the home. The rest of it is delivered outside the conditioned space. So if we have ducts that are completely inside the conditioned space, most of the air does get into the home. And with duct sealing, if we can make an improvement close to 20%, that's better than an increase from an 80% furnace up to a condensing gas furnace, or for most cases with a heat pump, any improvement in HSPF. One of the major benefits is happy customers. In this example, the homeowner wrote into the utility and to the contractor, let them know what a fantastic job they did, and that she noticed greater airflow out of her registers and energy savings on her utility bill. We all strive for happy customers. There are two types of duct sealing incentive pathways. PTCS duct sealing, which does require the pre and post duct leakage testing, and also prescriptive duct sealing, which does not require the duct leakage testing. Check which pathway your utility offers. Some of them may offer only one of these two, and some of them may offer both. For prescriptive, other than not requiring the pre and post duct leakage testing, all the other specifications will remain the same. And you'll need to check with your technician's certification type to ensure that they can meet either the PTCS duct sealing or prescriptive duct sealing requirements. So what's involved for PTCS duct sealing? Measuring the duct leakage with fans. We do a leakage to exterior test, which the technicians have been trained for in the class. Then we seal all the opportunities. And then measure the leakage again to find out what the difference is. And remember, prescriptive duct sealing does not have this leakage measurement requirement. Items you'll want to know before you begin are if the ducts have been previously sealed. So there's a specification indicated by the red file folder off to the left. And one of those specifications say that the ducts must not have been previously sealed through the program. There's ways to check that, as indicated in that second bullet down, which, if in doubt, you can do a previous search on certifications to find out if it's already been sealed, or unless a utility, through a pre-inspection, confirms that there's still opportunities for sealing to be done. And then another specification is at least 30% of the ducts must be located in an unconditioned space and are accessible. Note there, ducts that are in basements are considered to be in the conditioned space. Outside versus inside. This graphic represents a home, and you can see that the attic is definitely outside the conditioned space, the crawl space, and even a garage where the air handler is located in this graphic would be outside. And inside the home, obviously, is inside conditioned space. The leakage requirements for single-family homes fall into two categories. Pre-sealing leakage, and that's going to be based off of the home square footage. So if the home is larger than 1,667 square foot, we have to have a leakage before we start doing any work of at least 250 CFM. If the home is less than 1,667 square foot, we have to have a leakage that's equal to or greater than 15% of the home square footage. So an example would be a 1,000 square foot home. That would fall into that home less than 1,667 square foot. And the leakage would have to be 15% of that square footage. So if it's the 1,000 square foot home, we'd have to have a leakage of at least 150 or more in order to be able to start doing work. And then the post ceiling leakage, so we have to meet one of these two requirements. And so the CFM leakage after sealing has to be a 50% reduction, or the CFM has to be equal to or less than 10% of the square footage of the home. And so using that same example of the 1,000 square foot home, we would need, and we tested in at 150 CFM of leakage, we would need to get that down to at least 75 CFM to get that 50% reduction, or down to 100 or below to meet the 10% of the square footage of the home. And also remember, prescriptive duct sealing does not have these pre and post leakage requirements. The leakage requirements for manufactured homes. Before we start doing any work, we have to test in, find out what the pre-sealing leakage is. And that's going to be based on how many sections of the home has. So single wide, we have to be greater than 100. Double wide, we would have to be equal to or greater than 150. Triple wide, equal to or greater than 225 CFM leakage. And then the post sealing leakage, we would have to have at least created a 50% reduction, or for single wide, equal to or less than 50 CFM. Double wide, equal to or less than 80 CFM. Triple wide, equal to or less than 110 CFM. So, and also that reminder again that prescriptive duct sealing does not have these pre and post leakage requirements.
For the initial inspection, you want to find the major problems. You want to check for building cavity returns. They're pretty prevalent in older homes. Decide whether duct sealing is enough, and then also decide whether parts or all of the duct system needs replaced.
Occupants of the home have a lot of information about the homes they live in. Here's some sample questions that might help you. Do you have rooms that are hot or cold? It may help find duct disconnects or proof of poor duct design. Do you pay high energy bills? It gives them an opportunity to express that frustration if they do pay high bills. And if you're familiar with typical energy use in your area, looking at those bills can give you a wealth of information. Continuing with questions for the occupant. Do you notice any unusual smells when the furnace air handler turns on? You know, garage odors, crawl space odors. This can give you some solid clues of disconnected ducts. Do you notice any insulation on your furnace filter when you change it? Insulation on the furnace filter is another good indicator of serious duct problems in the attic. I had some insulation in my register recently, and when I investigated, I found that a mouse had chewed through the supply a flexible duct, and the insulation ended up in my register. So I was able to identify that and repair it. Do you have any combustion appliances or a carbon monoxide detector? We'll cover why you'd want to ask that here in a little bit. Conducting a visual inspection. Look for the real obvious tests inside a home, like does air come out of the register? If not, a damper might be shut, or it might be due to a disconnect. When you remove a register or grill, do you see ductwork, or do you see the attic or a crawl space? These are great ways to identify where the areas that need to be addressed are. Here are some images from a visual inspection. The upper left, we have a never connect. Duct was there, boots there, but no hole in through the floor to be able to deliver that air into the home. In the middle on the top, we have, it looks like some type of dryer vent style ducting. You know, and some tape, and looks like a lot of leaks there. Upper right, we have a takeoff that was tabbed into a plenum or some type of supply duct, it looks like, and looks like it's pretty severely leaking. Also on the bottom left, we have gores of an elbow. Those leak pretty bad. Bottom right, we have a flexible duct that has been pulled off, disconnected. And these are great ways to identify areas that need addressing in duct sealing. Now we're going to talk about insulation. So in the image there on the bottom, you can look for signs of dirt on that insulation. That can easily be identified as a duct leakage area that's leaking that air through that insulation. So it's a filter at that point, and it's known as ghosting. Also, insulation is not a barrier to accessibility. This includes attic insulation. So with attic insulation, you need to move the insulation out of the way, seal the ducts, put the attic insulation back to as good as when you moved it out of the way. Also, when insulation is removed from ducts, it shall be reinstalled and securely attached with mechanical fasteners. Duct sealing really leaky duct systems can be quite problematic. If you have a catastrophically leaky return, like pan floor joists, cavity returns, there's a specification that allows for a supply side only test to be used to determine that duct leakage. Trying to seal up a cavity return or a pan floor joist might not result in much CFM reduction. And so we have this stipulation where if this is the case, you can separate the supply off, typically at the filter location at the furnace, and test only the supply side to get your leakage numbers. Make sure you indicate that on your documentation. What problems are you trying to fix? Comfort issues usually requires re-engineering, so don't overpromise results. If a room needs 300 CFM, the ducts need to be large enough, and duct sealing might not be enough to be able to take care of that issue. When to replace duct components. If the duct system's falling apart, you have rusted sheet metal or rotting flex duct, or duct board that has some of the air barrier missing, it's often easier to replace some of those duct components than trying to repair them and seal them. And oftentimes it's easier to sell too. Keys to a complete duct seal job. Remove the old tape, mechanically fasten and make sure necessary repairs are made. Put tension ties on the inner liners and outer liners of flex duct. Put screws in the metal duct connections. Support the ducts. Fasten boots to the subfloor. Seal the ducts with UL 181 listed mastic. Plug don't paint. The specification says mastic should be as thick as a nickel. And that is from the manufacturers. In order to be able to seal properly, the mastic should be that thick. Tape is only allowed on the air handler to plenum connection or an access panel. And with insulation, once the ducts are sealed, it needs to be reinstalled. Fasten, support, and seal them. The specification says all accessible portions shall be repaired, mechanically fastened, supported, exposed from the insulation, sealed with the appropriate materials, and then re-insulated. Below we have some areas that definitely need addressed. Air handler to plenum connections, joints between the metal ducts, supply and return plenum joints, seams, caps, and corners, gores on the elbows, inner and outer tension ties on flexible duct connections, takeoffs, seams on boots, Ys, Ts, and splices, and for manufactured home, the crossover, and also end caps. The distance rule. The greater the distance from the fan, the more a leak becomes a hole. At the furnace is where the greatest pressures in the system are. Also, the hottest and coldest air. Right at the furnace, the air handler is where we really need to sweat the details to make sure that air stays inside that duct system and gets delivered into the home. A reminder, testing ducts takes specialized equipment, access to registers, and time to test in and test out. There are equipment discounts available, and that'll be discussed in the next section. Also a reminder, some systems might already be too tight to apply for an incentive, so those pre-leakage requirements are important to remember. And trying to get a duct system tight might be an issue, and the incentives might not be available. Might be important for comfort, but no incentive will be available because there's just not enough energy savings available for the utilities to pay an incentive on that.
If anybody's using the AeroSeal equipment, AeroSeal is approved for use with PTCS with a few exceptions. You have to add a note into the registry entry. Both supply and return sides of the system must be sealed. All the other specifications are still required, including duct repair, tape removal, supporting the duct systems, mechanically fastening them, and testing. You still have to do a test in and a test out leakage to the outside. Still required use of the blower door. The system must be tested at 50 pascals. I know the equipment is typically set up to test at 25. And leakage to outside test results must be for the entire system, supply side and the return side.
Combustion equipment. Whenever we have combustion equipment, we need a CO alarm. It's required. If there's anything that burns any fuel in a home or attached structure, like a garage, the program requires that a carbon monoxide alarm be installed. No matter what fuel it uses, gas, propane, fuel oil, wood, pellets, etc., just something that burns, we need to have that carbon monoxide alarm in the home. Potential negative effects of duct sealing. You get a lower dilution rate. And so what that does is carbon monoxide might build up in a home and not be able to be diluted through the natural air infiltration that happens in a home. You create backdrafting of combustion equipment. So you need to be aware of unvented appliances, like the picture in the center, a fireplace without a flue pipe, or a natural draft appliance, like a natural draft water heater or a very old gas or LP furnace, or cracked heat exchangers in a gas furnace. And so it's really important that duct sealing companies have a plan to reduce their liability in this area. The technicians have been trained on blower door safety, but we want to reiterate that. Do not use a blower door or a duct blaster if you see fire or ash. Fire, you could create a blast furnace. Ash could be distributed throughout the home by these fans. And ash contains a lot of oils in there, in the ash, and really makes it difficult to come out of carpets, furniture, draperies. So a good idea is to notify the homeowner to ensure that if they have the fireplace or wood stove, they completely extinguish that prior to the scheduled duct sealing day. And then also, if you want to manage loose ash that might be in a fireplace, you could seal off the fireplace or use wet newspapers to do that prior to running the test.
Another safety concern is asbestos. You should not use a blower door or a duct blaster if you see or suspect that asbestos-containing materials are present. So in the picture on the lower right, you have vermiculite insulation, which could have asbestos-containing materials in it. And then also a little more prevalent is asbestos-containing tape on duct systems. If it's friable, it can be distributed through the air with a blower door or a duct blaster with these fans and potentially create a health hazard. It is recommended to stop work immediately, notify the homeowner that the site requires professional assessment and possibly remediation before work or testing can be done.